In the previous section, you were introduced to the first new features of C# 8, and this one, we will be studying new features but with a closer look into how we can improve coding data collections. In this video, we will upgrade switch statements with pattern matching. Now let's see how this is going to work. We are going to create an error handler class like we did in the previous section, only this time we are also going to create some custom exception files. So we are going to create classes that will essentially inherit the exception base class, and we are going to use them in the error handler and see how using patterns with switch statements produces way more readable code than using either an if-else structure or traditional switch statements. So let's go ahead and create our first custom exception. I'm gonna call it HTTP error. I use the error keyword instead of the exception keyword because an HTTP exception class already exists and we don't want to mess with the namespaces. So let's say that for an HTTP error, in order to describe it, we need the status code. We can either use a string or an integer, depending on what we will need later. Let's stay with a string now, and perhaps we're going to change this depending on how the error handler will end up being saved. And we also need a description. Now, I'm not talking about the status text like 200 OK or 404 not found. I'm talking about further description of the error. Or perhaps we can also stick with the status text depending on how much detail we want to expose to the logging service. Then we can have a constructor that can help us with quickly bootstrapping an HTTP error. So the first argument is the HTTP code, the second argument is the description, and we are okay with that. Now let's go ahead and create another error file, another custom exception, and let's call this. Now, what should this be? Let's say that we have external services like third-party tools, and one of them fails. We should be able to identify which service failed, and therefore, ideally, we would want to wrap all of those errors in an external service error that inherits from the base exception class. Usually, when you have something like this, you just need to know the actual service that failed. So it is important to state the service name. Let's store it as a string. And also, we can keep an error message, but for that we can rely on what is provided by the base class. Therefore, I'm going to create a constructor with two arguments. The first one is the service name, and the second one is the message, but we are going to pass that message to the base class constructor. So there you go. I'm adding a second argument called message, and then I will immediately invoke the base constructor like this, passing in the message. As you can see, there is an overloaded constructor for the base exception class requiring a single string argument describing the message. And now we are back at the root of the project, and we can finally create our error handler class. Let's remain simple so we can focus on adding patterns to switch statements. Therefore, I'm not going to create an interface for this error handler like we did in the previous section. We're just going to have two methods. The first one is the one that will eventually be called by the error handling code in other parts of the execution. And this one should expect an exception object, and this, how it handles it, is going to depend on the actual strategy. We're going to go with a console.writeLine. But whatever strategy we choose, we need a complete error message, like what is going to be printed, either on the console or on a third-party logging service or in a database. This is where we need to convert the actual exception into an error message, and this is where patterned switch statements sign. This is the format. Actually, we need to change that to string because we return a string, and we use the switch statement here to match the error object with several patterns, not just types. So we are not forced to have one line for HTTP errors and then one line for external service errors. We can actually have multiple lines of the same error type, as long as, of course, we have some type of variation inside the pattern. So let's say that in the case of an HTTP error, and this is going to do some type checking and find out if the error exception is actually an instance of the HTTP error class, and if it is, it will then go on and execute the code that is followed by the when keyword, which will compare the HTTP code with, let's say, the range of HTTP codes that do not correspond to an error. Perhaps in that case, meaning codes between 200 and 300, perhaps we want to say something like no error. For some reason, we felt the need to throw an exception, but in fact, this HTTP error code doesn't represent an error. It's just a status code representing an operation that went well. Now, this red line means that we have to go back to the HTTP error and change its type from a string to an integer. Make sure to change it both in the constructor and in the actual property. And back in the error handler, on the next line, again, we can have HTTP error. The compiler is not going to complain about that. Only this time, perhaps we want to compare HTTP codes in the 300 range or above. In that case, we want to log the error because it is an actual error with a more complex format like this one, followed perhaps by the description. Then it's time to pattern match the external service error. Of course, you can have pattern matching without using the when keyword, but this is going to run every time we have an external service error since we didn't provide additional conditions into this pattern. And finally, you have to never forget this. You need to use the underscore for the default case. If you don't use this one, you will risk having an exception thrown every time your pattern matching logic is run. Because if it doesn't match a pattern, it's going to throw an exception. So always provide a default case. Now, let's run the application. Back to the main method. I'm going to add a try catch block and throw a series of exceptions and see how our error handler ends up handling them. So let's first throw an HTTP error. And if we run the application, we expect to see the no error line printed. And of course we do. Now, if we close this window and throw an HTTP error again, actually I'm going to comment this one out so you can try it out in the code files, comment the errors that you want to throw. And let's change the error code to 400, which is equal to bad request, and rerun the application. Good. We get the proper error format. Let's comment this one out too. And now let's throw an external service error. Let's say that the service that failed was the Azure Service Bus, for example, with an error invalid payload. All good. We can rerun the application. And we get the name of the service that failed before the actual reason why it failed. Perfect. Pattern matching seems to be working. One final test, we need to check the generic case, the case in which our error object goes through all of the available patterns and it doesn't find a match. Therefore, this is important. We should not get an error here. We should have something printed, unknown error, which means our error handler with switch pattern matching worked.